Now, you need good tools to do this. You can build everything yourself if you want, but then you have to realize, is this the core of my business? Your IT teams, you as developers, should be focusing on innovation. You should be using the right tools to build upon your performance monitoring tools and really
build everything yourself if you want.
Sorry,
then you have to realize, is this the core of my business?
A slight echo.
Your IT teams, you as developers, should be focusing on innovation. You should be using the right tools.
Shut down. Okay,
there we go.
good.
Sorry.
Okay. Okay, no worries. So, you know, you as developers, as technical people, you need to be focusing on doing cool things. And building a monitoring solution as such is not really a cool thing. Well, I consider it to be a cool thing, but that's something else. So, why is performance important and monitoring important? You want to avoid downtime, right? You want to lower the mean time to repair. So if something goes wrong, you want to be able to react quickly. You want to understand where a problem occurred so you can react quickly. You want to be able to pinpoint someone or a team or a specific part of your application to quickly solve your problems. And finally, in the end, you want to improve your customer satisfaction, right? If you have a website, you're selling products online and your website is loading slowly, your customers will not be happy and they will go to your competition. So the end goal of having a good performance is, of course, to increase customer satisfaction. So let's have a look at how we were doing monitoring, performance monitoring before. So for a traditional monolithic application, we were doing the traditional system and infrastructure monitoring at the operating system level, either your virtualized operating system or or directly running on bare-bone hardware. Then you had your application running. So we were typically doing what's called application performance monitoring, so the traditional APM tools that monitor, okay, how good is my big monolithic application working? Where are my bottlenecks? How much time am I spending in maybe some kind of function inside my code? So that's like the traditional stack in a monolithic application. And finally, we have our end user experience, and measuring performance from the point of view of your end user is called real user monitoring. So this is where you measure how long does it take to load my web page, which requests are we asking from our backend infrastructure, etc. Now, obviously, when using Docker containerized environments and using Kubernetes, for example, as an orchestrator, we have more challenges here. So we now have this new layer, called the orchestrator, as you all know well. So we need to understand how this orchestrator is behaving. What is it doing? We now have our containers that are running. So we're creating smaller components. We're building microservice applications where each of our components is smaller than the very big monolithic applications that we used to build before. So it's important to understand how these containers are behaving and how the microservice components inside the container is behaving as well. So in a microservice environment, it's still important to understand what's going on at the operating system level, right? You still want to know, okay, how many CPU loads, memory uses am I consuming? That's still important. At the orchestration level, you want to understand, okay, how many services do we have right now? How many containers do we have running for each of the services? Which volumes do we have? Which volumes were mounted and how am I using these storage volumes? So that's an additional layer that adds complexity, and that's important to keep track of from a performance point of view. Next to that, we have our containers, of course. So we want to understand how much resources are our containers using. So how much CPU load, memory usage are they using? This is comparable to our traditional infrastructure monitoring, but now at the individual container level. And then next to that, we want to understand what's happening inside the container. So if you have a web service running, maybe a caching layer, a database, any kind of technology running inside your container, you want to understand, okay, how is it performing? Are there any bottlenecks? And to get a good idea about what's going on. Obviously, we still have our end user experience. So all of these layers, this is what's really important about monitoring your microservices, all these different aspects. Now, why is this challenging? The scale is very different. When you're building microservice applications, you have typically many more components. You have much smaller components, And what we see is that you're using a much higher number of containers than you were using servers or virtual machines before. So this is important because there is a challenge if you want to monitor each of these containers. Now, on top of that, your containers, they come and they go. You're starting them, maybe a minute later, an hour later, or whatever, you're stopping them again. So this is very dynamic. So you need to take this into account if you want to think about performance monitoring. Something else we see is that a lot of our customers are using much more technologies than they were using before. Because when we implement a microservice application, we're using the most appropriate technology to solve the specific task we want to build a component for. So we're using diverse technologies, and each of these technologies has its own important metrics to keep an eye on. So this means that we're monitoring a lot more metrics. And then there's a challenge again, because how do you alert on this? How do you keep track of this? Do you want to look at all these dashboards manually, containing all of your metrics? So a lot of challenges here. Now, if we do a small calculation about the number of metrics we're monitoring today in our microservice applications, then, so let's start with our traditional monolithic application, where, for example, we're monitoring about 100 metrics we're getting from our operating system, the traditional metrics I discussed, like CPU load, memory usage, etc. And let's say we're monitoring about 50 metrics from our application. So this gives us about 150 metrics per host to monitor, right? Now, in our container environments, we suddenly also have the orchestrator, where we keep track of about 50 metrics. And then for each of our containers and the applications running inside the containers, we're also keeping track of additional about 50 metrics. This is a quite conservative number. So we actually see that customers or people are keeping track of more metrics than 50. So if we assume that you're running 10 containers per host, you easily end up with having more than 1,000 metrics per host. So this is getting crazy. I mean, how do we keep track of all of this? So there are a lot of different ways of keeping track of all of these metrics. And I want to go through a few possibilities of doing performance monitoring. And then I want to talk a bit about what CoScale exactly does. So the first way of gathering performance metrics is to use the Docker Stats API. Now, if you use the Docker Stats API, you get like a command line overview like this. This shows you basic resource consumption of the containers running on this node. Now, this is easy to use. It's like a top on a Linux machine, so you can get some metrics on your command line, but obviously this does not scale to a larger cluster. This does also not give you application performance metrics or any end user performance metrics. But this could be useful sometimes for debugging if you're logging into the server and want to get a view on the resource consumption. Now, another tool that is out there is called cAdvisor. This is actually a tool that was developed by Google, and cAdvisor allows you to have these nice dashboards that basically take the Docker stats, so the similar metrics from the Docker Stats API, and present them in a dashboard. So this is easy to do. You have the Docker command right here, and then you just point your browser to this port, and then you get these dashboards. Again, this is limited to one node, so it is good to have a view. Okay, what's happening on this node? How many resources are we consuming at this moment? But this does not scale to larger cluster environments. But in some cases, for your applications, this might be sufficient. Now, then there are also some commercial tools available that I quickly want to give you an overview of. One of the popular ones is Datadog. With Datadog, you actually use their agent. You either run it inside a container or directly on the host. And Datadog captures resource information, like the things we saw before. And it also does a little bit of basic application monitoring. So they have some plugins for technologies like Apache or any other technologies you want to gather some more application-related metrics. Obviously, a commercial tool comes at a cost. They have nice dashboards for sure. Another popular tool is Sysdig. And I think Sysdig has a really cool approach because they use a kernel module what they basically do is they capture all the system calls that are being done by your containers that are being passed through the underlying host operating system. I think it's a cool approach. What we see is that this approach is suitable for startups, smaller enterprises, but bigger enterprises typically have an issue because you have to install a kernel module, which is the core of your operating system. So from a security point of view, also from an overhead point of view, this is typically a no-go for larger enterprises. Sysdig also offers let's say the traditional resource monitoring and also some basic application monitoring. Now, you probably all know the traditional APM vendors like New Relic. I think New Relic is probably the most popular one. These tools were all built for traditional monolithic applications. They have a heavyweight agent that gets into your application stack that allows you to understand what's happening inside your code. If you have a Java application, you can see, okay, how many time am I spending in a specific function, which made a lot of sense in our big, complex, monolithic applications. But these tools really are not built for our lightweight microservice architecture we're building today. On top of that, with the complexity we have with the huge amount of metrics we're monitoring today, these tools do not take into account the dynamic behavior, and they're also not built for handling this large amount of alerts, large amount of metrics. On top of that, most of these APM tools require you to install an agent inside your container, which is basically an anti-pattern. You don't want to be running a heavyweight agent next to your application inside your container. So obviously, these tools are also quite expensive. So what we usually see is that these tools in a production environment are sometimes used on like 10% of the production environment, more for debugging purposes, and then other tools are used to monitor the entire production environment. Okay. Now, obviously, there are also a lot of open source tools available there. Now, these open source tools, I think Prometheus is one of the most popular ones today for monitoring Docker environments. They're very easy to start with. There's a large community with good documentation to get you started. But if you really have a big production environment, if you really want to do production monitoring, then there are a lot of limitations on these open source products. And you really need commercial support. You need companies like EndoCode that deliver great services, that understand the ecosystem, that understand these technologies by heart, to bring it to your production environment. So that's why the guys from EndoCode are doing really great work. But all of the open source tools available out there, if you really want to scale to a large production environment, the essential components are usually missing. This is similar for Docker. I mean, you have Docker Data Center, you have, for managing larger scale applications, you have their security tools provided by Docker. This is not part of the free open source. This is part of the commercial enterprise version. So if you are serious about running a large scale environment, production environment with Docker, with Kubernetes, then you might have some challenges around using these open source technologies, and you need good companies like EndoCode to support you, or you need to think about using more commercial oriented tools. Okay. Typically, these, like Prometheus or the other ones listed out here, are more generic tools. They were not built specifically to monitor Docker environments. And what we see is that they, for example, they don't do real user monitoring. They also don't offer out-of-the-box anomaly detection. I will come back to anomaly detection later, and other analytics. So let's talk a bit about anomaly detection. So the point I want to make here is the amount of metrics we're monitoring has exploded. I mean, that has become clear during my talk, I hope. So there is a need for advanced analytics. It's not feasible anymore to keep track of thousands of metrics manually. You need automated techniques that help you understand what's going on. And this is the case for anomaly detection. So what is an anomaly? An anomaly is something that deviates from the normal behavior. So basically, anomaly detection models learn the normal behavior. They learn automatically how your application, your users, your infrastructure is behaving. And if something deviates, if there is a bottleneck, if there is a performance issue, anomaly detection automatically warns you and helps you figure out what's going on. That's what it's about. The traditional way of detecting problems was to use static alerts, and static alerts have their use cases. I mean, there are data patterns where a static alert works fine. For example, in this case, if you have a clear peak up, you might come up with a good threshold that is triggered when this peak occurs. But obviously, there are a lot of limitations to static alerts. For example, what if you have a lot of seasonality in your data? If you have maybe less customers during the night or during the morning, more during the afternoon and the evening. So you have to take this into account if you want to do alerting, because if you pick a threshold right here, well, then you will never be able to detect problems during the day. So this is very difficult to to choose good thresholds for these when you're having these seasonal patterns. Next to that, in the data we're measuring, there are a lot of correlations. So, for example, the number of users that are using your application or going to your website has an impact on the number of requests you're handling, your backend services handling. So the number of requests per second is directly correlated to the load on your system, to the CPU load. So these are kind of correlations that you need to exploit. You need to take into account when thinking about alerting and doing anomaly detection. Now, like I mentioned before, we're building these very dynamic, scalable environments. So picking the right threshold doesn't make sense anymore, because our environment will have changed in a few weeks' time. And it's changing from day to day. Maybe one day we're running 100 containers and the next day we're running 50 or 200. So it's really not easy to come up with good thresholds, static thresholds these days. Okay, so let's talk about CoScale a bit. So at CoScale, we offer a full stack performance monitoring platform specifically built for microservice environments. So with full stack, I mean all the layers, all the components we talked about earlier. The CoScale platform has been built for production usage. So we use a lightweight agent that you can easily install on each of your nodes, allowing you to keep track of all important performance metrics in a production environment. We use anomaly detection techniques to help you understand what's going on in your environment and detect problems as quickly as possible. We give events to your data, and these events, they give additional context. And a typical example is when you're doing software deployment. So each time you do a new software deployment, maybe you're using Puppet, Chef, Salt, Ansible, whatever kind of config management tool, you want to keep track of each of these deploys because they might have a performance impact. So this is what the events are really about. The CoScale platform is very easy to set up, easy to deploy, easy to use. We offer our software in our own SaaS platform, but also on-premise. So our on-premise software is completely offered as Docker containers, obviously. So it's easy to install, to upgrade, etc. We like to be very open about the architecture we use, because our complete architecture has been built on open source technology. So I will not go into too much detail here because I only have 30 minutes. But basically what I want to talk a bit about is our data backend. So we use a Postgres cluster for storing metadata. So just storing information about, okay, the services we're monitoring, the type of containers, some configuration data. But all of the time series data, so the real metrics, the CPU load metrics, the latencies, this is all stored in a Cassandra cluster. Now, in order to be able to horizontally scale this Cassandra cluster, we've done some tricks. So Cassandra has the concept of column families, and we use these column families in a few different ways. We use them to split our different aggregation intervals. So the default interval for our data metrics is 1 minute. So we capture one data point every minute. But if you want to look at 6 months, a year of data, you can imagine that returning a data point every minute is not feasible. Your browser will crash. So we're rolling up the data, we're aggregating the data. And this is basically a layer where we've built on top of Cassandra to do this aggregation and to do proper sharding as well. So we use Elasticsearch, an Elasticsearch cluster for keeping track of the events I talked about, the contextual events. The interesting thing is that we can store some more information in Elasticsearch, some more textual information, even binary information, to get some more context around these important events. All of our services, so all of our, we call them workers, communicate over a set of RabbitMQ nodes through our API layer to do useful things. So this is where the anomaly detection is running, where our alerting runs, where some of our other workers are doing useful work with the data. So most of these components are completely stateless, so allowing us to scale our architecture perfectly horizontally. Now, I want to tell a short anecdote. We used this architecture at a proof of concept during the summer with the largest worldwide CDN. And we were able to handle more than 1 million metrics per second using our architecture, just to show you, how it has been built for high scalability. Okay, let's, how much time do I have left? Okay, I think I have 5 minutes, right? Good. Let's have a look at a few dashboards. So I talked earlier about the huge amount of data we're capturing. So if you're building dashboards, you want to focus on the most important KPIs. You can easily add 50 line charts on a dashboard, but you will get lost. So you need to start from the most important high-level KPIs. And in this case, we're looking at one of our customers. They have 4 services. So for each of their backend services, they're just visualizing here, okay, what is the latency, the average latency at this moment? You have colors indicating if latency is fine or not, and you have like these indications in the top right corner, and this is how does the performance compare to last week, the last day, whatever. This can be configured, of course. Now, below these like high-level KPI widgets, we have what we call a performance heat map. And a performance heat map splits the performance of each of the services over the different containers running for this service. So this gives you a bit of an idea about, okay, how are my individual containers doing? Each of the rectangles represents, in this case, 1 hour in time. So this also gives you a short, small historical overview. Let's have a look at a few other examples. There is another, yeah, the resolution is a bit low, but anyway. This is another example of this is an e-commerce application, and this customer is also keeping track of some business KPIs. So in the CoScale platform, we offer a REST API, so you can push your own custom metrics to the platform as well. I talked about starting from these high-level KPIs. Now, if you want to know more, if you want to get more details about the performance, what you can do is you can drill down. So for example, I can drill down on this average page load time metric to get more details about my end user experience. So what I see now is I get a dashboard. The different colors are different web pages in our application. So we're visualizing, okay, how many page views are we getting per second? How is page load time changing over time? You see 2 lines here. One is the average, one is the 90 percentile. And then at the bottom, let me quickly make this a bit bigger here. So this also shows how easy it is to customize our dashboard. So you can easily drag, drop, resize. We have a widget library with a ton of widgets. What I want to show here is we show you a top 10 of slowest web pages in your application. So allowing you to focus on what's important. You see some performance numbers here, but again, you can drill down. It's asking me to save the dashboard. Again, you can drill down. So now I clicked on a specific web page and I'm looking at performance numbers for this web page. So how many page views do we get? How is page load time changing over time? And what are the individual resources that are being fetched by this web page from our backend microservice application? Again, you can drill down on any of these resources, or any of your API calls, and you're now looking at the performance as measured on your nodes in your backend. So you can see some kind of patterns here. Interesting thing here is you might have noticed or recognized the Puppet icon. So every time you do a Puppet deploy, so we have integration with Puppet and all these tools, so we automatically mark these deployments. And interestingly, you can see that all of these Puppet deploys are actually interesting insights about what's going on. I'm going to skip this one, but I'm going to first show this. This is, maybe I'll put it a little bigger as well. Okay, this is an OpenShift cluster. For those of you who don't know what OpenShift is, so Red Hat OpenShift is a PaaS platform built on top of Docker and Kubernetes. So this is an environment where we are monitoring OpenShift. What we show at the top here is an overview of all of the replication controllers in this OpenShift cluster. And if you see like this red indication, then this means that there is a problem with one of the services. So in this case, I can actually hover over it. Then this means that there are not enough containers running for this service. So this is indicated here. Now, something else you can do, you can also, by click on this Elasticsearch service, I'm taken to a dashboard that shows me, well, I didn't click on the best example. This is quite static because there are always 5 containers, but if it's in a more dynamic environment, you would see the number of containers going up and down here. And at the bottom here, you will see like an overview of the individual containers and their life cycle. So the green area indicates when the container is up and running, right? Okay, let's go back to our previous dashboard. So there was another interesting visualization here, and this is interesting for visualizing a larger cluster. So in this case, each of the green circles, the inner circles, they represent your host server, and the smaller circles around it represent the containers running on this host. Now, as you can see here, there is one container marked in red. So this is actually a container that is consuming more CPU load than expected. I'll switch to a different dashboard where I will show you this. So this allows you to quickly identify which containers are behaving bad and which ones you need to focus on. Yeah, so let me first show you this one. This is actually the container I talked about. So there is this container. So suddenly this container goes through the roof. There is like it's stuck in a loop, and an endless loop, and it goes to 100% CPU load. This was the problem that was automatically detected by our anomaly detection. So as you can see here, our anomaly detection highlights that this was not expected behavior. And this was also visualized on the previous dashboard. Now, let me give you one other example of our anomaly detection. Just I'm struggling with the shortcuts here. Okay. Let me quickly just open this page again. So I also want to show you an anomaly that was detected here in this application. So we do anomaly detection at different levels, and in this case, there is a problem on 2 of our backend nodes. So if I click here, I get some more details, and I see that on average, there is a 27% increase in CPU load. So I can click here, and I get a similar view as we saw before. So our anomaly detection highlights the problematic behavior. So we know that during this time of the day, this is not an expected load on our system. And the result of this higher load is actually a performance penalty. So there is on average a 5-second increase in our latency. You can also click here and then you get some more details. So we're showing a latency distribution here. So basically this means what percentage of your users is experiencing a specific latency. Okay, good. So in the CoScale platform, we have many more dashboards that show you more specific performance KPIs about the technologies we monitor. This is a typical example for a caching layer. In this case, it's a memcached technology. So when our agent detects a technology like memcached or whatever, we automatically generate these dashboards with the most important KPIs. So in this case, your cache hit ratio, the number of items in the cache, and the amount of memory used. Other examples are like this, where we're looking at a relational database, where we are showing you a top 10 of slowest database queries, right? Okay, good. So I think this should give you an idea about what we are doing. Let me quickly switch back and end my talk. Okay, so before we jump into the questions, we are organizing a Docker event on how to operationalize containers. So we are organizing this in Frankfurt on the 1st of December. We have an interesting talk by SAP. They are talking about how they the challenges they had of bringing Docker and microservices to a production environment. We have a very exciting talk from Docker itself. So we are a Docker Premium partner and also a Red Hat Premium partner, by the way. But they're going to talk about how to secure your entire software lifecycle. And this is really important because a lot of people have bashed on Docker that it's not secure. And in this talk, Stephen Thwaites from Docker will really explain, okay, what are all the steps you need to take into account if you want to build a secure development lifecycle. So I invite all of you to take a look at our website here, CoScale.com, Docker/roundtable-Frankfurt. If you're interested to join, you can register. Good. Feel free to reach out to us. My colleague Guntram is also sitting at the back there. Come talk to me after the meetup if you want to know more about us or if you think we will be able to help you. And I would be happy to answer your questions right now.
Thank you very much.
Any questions?
I have one. I see great product. Congratulations.
Thank you.
Awesome. I would like to ask you something about how do you see this, what I call micro monitoring? Because in a large scale scenario, you have like hundreds of containers, hundreds of nodes, different clusters in different clouds or whatever. And I would like to know how much matters having this micro monitoring instead of having like micro monitoring instead of having a micro monitoring that says, okay, that's my service, that's their role. How can I keep the constraints or policies running on top of that and not just looking at this tiny small container? Because containers are ephemeral, you can just drop and reload another one or bring another one. So
that's a good point.
How can you see this?
And I skipped one dashboard that would have answered that question. Okay. But so basically, monitoring different layers is important. And I showed the anomaly example of a container problem. We're also looking at the entire service. So what you're saying is, for me, it's important how many requests is my entire service handling? What is the performance of this entire service? And maybe you don't really care about if there's one container behaving bad. Okay, I'll drop it. And so yeah, that's a very good point. So we also have the notion of services. We understand what services are. We do anomaly detection at the service level as well, at the container level, at the end user experience level. So at the different levels, and that's really. Yeah. I didn't go into that. But yes, a good point. Yeah.
Okay. And another question is, how are you guys think in applying some kind of machine learning to understand the scenario, or even not like a reactive action? You can just be like a proactive or more. I see, like, okay, I know that's going to be wrong or whatever, something like that. And how can you see machine learning helping you in not being so reactive, but instead of being proactive? I mean, if you deploy a container and you start having some kind of bad behavior, you can just, I don't know if it's possible to predict any situation.
Yeah, so I talked about anomaly detection. We also do trending, forecasting, and that's something that's more towards the future. I didn't show anything about that because the time was a bit limited. Another point I want to make there is all the anomalies, the alerting, can be attached to webhooks. So for example, we have customers that use the anomaly detection. If they detect suddenly there is a service overloaded or there are more requests per second being handled, then they use a webhook to start more containers or do something, restart something or whatever. So this allows you to react to it, and proactively add more containers or reduce number of containers or whatever.
Yeah, thanks.
Okay, well, thanks for the questions. Any other? Yeah.
How do you deal with false positives from the anomaly detection? Do you have a way to fine tune like silence? Or?
Yeah, I'll send you my PhD. No. So this is work. So I've been working together with my colleague on performance models for about 7 years. We use we use a lot of different models, basically. There is no such thing. Some vendors claim we have a mathematical model that works on everything. That's bullshit. That doesn't exist. Yes. So we use different techniques. We have techniques that are more based on traditional regression models. We have techniques that are based on clustering techniques, like the k-means clustering, basically. We have techniques based on local outlier factor. I'm being very open about this because I've given talks about this as well. So local outlier factor, we have more like sliding window approaches. Different approaches because, you know, the different metrics you're capturing, a typical example, a CPU load pattern is very different from a memory usage pattern. And it's very different from an error rate pattern, a request rate pattern. It's very different if you want to do anomaly detection at the service level or at the container level. So, you know, all of these things, we built domain knowledge inside. So we tune the models towards, you know, the different metrics. And then we have like heuristics that, for example, sometimes different models are competing for what we call an anomaly score. So we give a score. And then we have heuristics that define, okay, what is the eventual score? You know, are there, or are there models that agree on a score? So these kind of.
There's not much fine tuning in there.
So this all happens behind the scenes. Yeah. Well, for some of our big customers, obviously we've, you know, tuned this, but yeah, no, this all happens behind the scenes. Yeah.
Thank you very much.
Okay.
I have to cut off. So.
No, sure. Okay, we can talk later.
Thank you. Das Kabel.
HDMI or from the board? Yeah. I'm good. Okay, then I need the.
Oh, okay. Yeah, next up is Steffen from Flixbus. He's going to talk about day-to-day life. And talk about
more developer than ops and the other way around. So developers. Okay, so perfect audience actually. You should ask like how many of you are PHP developers? Okay, they're not the right audience. Okay, so I'm going to talk about using Kubernetes as a development environment. Oh,
you can't see.
Can't see anything. Oh, maybe I need to. Settings here.
Just takes a little minute.
Oh, nice call. Went to standby.
Yeah.
Okay. Otherwise, it just might be my Linux.
No, that's not what it is.
So, something happens. Yeah. Yeah, perfect time to get another drink or go to the bathroom or. So good. There you are. Okay.
Okay, then I'm gonna make a bit settle down. Yes. Okay.
So you can see your slides here if you want to send a bit like there. That's great.
Ah, okay. Sure. Can I do it
awesome.
like this?
Yeah.
Awesome. Okay, so a little bit of background about Flixbus. It's a very fast-growing company. We're not very old, like less than 5 years, and we started with no developers, and then one of the first hires were developers, and now we are about 100 developers, a lot more other people. We have a big PHP application, of course, some smaller parts, but the huge part is PHP. And about 20% is customer-facing, 80% is like internal tools for operations, yield management, pricing, planning, all the internal accounting stuff. And right now we have about 3 Java teams and 6 PHP teams, plus some mobile and some other teams in IT or for development. There's a bit of background. And right now, when we started, or right now, we still have the problem that we have a mismatch between production and development, and that's actually especially important for PHP, because in PHP it's not like C++. Okay, I compile my binary, I ship it to production, and it's going to be the same as when I compiled it. And you really depend on your environment, like what PHP version, what extensions are installed, like really the patch level of these extensions are really important because they might just randomly break. especially if more complex applications. I think we use at least 5 or 6 custom, or like let's say 5 custom compiled extensions. So if you have a mismatch between production and development, it's just not good. And we have about 3 wagon machines in use for that. So we have the old wagon machine and the old wagon machine and the new one and the Puppet provision one and the Ansible provision one. And it's a huge mess. And so the easiest part is if you do onboarding, you just take the wagon machine one developer, copy it to the other person's laptop, and okay, it works. Which is also not really good. And it's really hard to integrate new services because you have these, basically everyone has a different wagon machine. So if you launch a new service that someone's depending on, okay, now I need to install it on everyone's machine, and everyone's going to have different problems, and it's just horrible. Also, we want to, we want to split up our big models. We want to move to microservices, and that means also we want to move to Kubernetes. So that's another background of this. So what are the goals for a new development environment? It should be robust, reproducible, and easy to use. And teams must be able to iterate their environments quickly and independently. So let's say I'm a developer in team A and I depend on a service from team B. I don't want to install a JVM or configure PHP or do anything on my wagon machine. It just work. And that's actually where Kubernetes and containers work really well. And developers should get familiar with the production environment because we basically in our IT department, people are responsible for the application of production mostly. Of course we have ops people, one of them sitting right there. And they help people, but still, in the end, you're responsible for your application. So you should be familiar. If you move to Kubernetes, like people shouldn't say, okay, I'm afraid of this. I don't know what's happening. I can't control this. And of course, the solution is Kubernetes in a Vagrant box. Obviously. So the good thing is about Vagrant is that it mostly works on all systems. You can use it in Windows, on OS X, on Linux. I don't care. It's quite proven now. A lot of people are using Vagrant. It works quite well most of the times. And there's minimal requirements on the host system. And you install VirtualBox, you install Vagrant, and it works. And we have good previous experience with Vagrant. So that's why another obvious solution to choose this. Let's say, another option would be, okay, let's use Docker Compose. Okay, but then you get problems with first integrating with other microservices. And also another problem is slow file system, especially on OS X. On Linux, you can just mount, you just mount it into your development. So maybe you need to go back a bit. So if you're a PHP developer, you're used to, you have a workflow, and your workflow is, I have my PHP files on my computer, I edit them, I press a file in the browser, and instantly I get the new code. It gets executed. And the problem is, modern PHP applications are a bit like Java applications. So if you press a 5, there's about 100 to 300 files that get loaded for this one request. And production is always cached, but on development, you don't want to cache it. So if your file system is really slow, you press a 5 and you wait 2 seconds just for the page to load. And no PHP developer wants that. So yeah, quick demo. Or maybe I was a bit too fast, so now let's go to them. But I cheated a bit. I wanted to actually show basically how fast it is doing Vagrant up and all this stuff. But I don't trust the internet here, so I cached all the things I could, and I'm not going to reprovision everything just because it might take a long time to get backups. But what I have here, so I have a Vagrant file in my project, and it's using our public Flixbus Kubernetes Vagrant box. It needs a bit more memory than usually. Also, we want to, so this is version Kubernetes version, it's using Kubernetes version 1.4.6. And my provisioning script, which we can take a look later, I want to get my credentials in there, my SSH agent, because obviously I want to pull from our internal GitLab or from our GitHub account, so I need my SSH credentials inside the box. And you want to use NFS, so we can get decent performance, and we, of course, need some tuning options, otherwise it's too slow. So now, let's say I'm on a machine. I would go into this directory and rig it up. And of course, the machine is already provisioned, so nothing's going to happen. Boring. But if I do Vagrant provision, It's basically what would happen if you start a machine for the first time. And what it's doing, let's go through it step by step after it's finished. Should be finished soon. Now it's finished. There's a lot of output. Okay, maybe. So first it's setting up like some more SSH options we can go into later. Not important right now, but it's applying my Kubernetes definitions, which I have in my repo. So here I have Kubernetes files. And for example, I have one for my application, where basically all the magic is happening. So I have 3 containers in there. I have an Nginx container because in PHP where you always have an Nginx or an Apache, and you have maybe PHP FPM, fast CGI protocol, really old school, everything. So we have 2 containers here, one for Nginx. We need to mount our files in there, so Nginx sees images and whatever, so you can load it directly from this. We want to have our Nginx configuration in there. And we have our PHP container, where we set some other options with the, I'm going to go into detail later, maybe. And we have, let me check. Here we have an SSH container, so I can directly SSH into this running pod, which gets important later, why I want to do this. And we define a service. And the special thing about this backend box is that I can access this service IP address from my host system. So now I can go into my browser and go to this IP address, and if everything still works fine, then I can load this page. And down there you can see the page load speed, half a second is okay. If everything is cached, it presses 5 again, it's actually quite good. 100 milliseconds is okay. And I click around here, and now I actually need to show how, let's say I would want to edit something. Let's go to the Twig template. Let's say I want to say hello Kubernetes Meetup. I save, I go to my browser, press F5, and it's there. And that's what PHP developers are used to. It needs to be that quick, and so you can iterate quickly. Yes. Yeah, so let's go back to provisioning, maybe. So now that I created all my pods, they're running now. I created the services, I can access them. Now what I need to do is I have a database in there. I need to provision this database with, first I need to create the schemas in there, the database schema, and I need to load some fixtures so I can actually see something. So this is a nasty shell hash, like shells loop, which basically waits for the pod to start. And then first it's going to install all the dependencies I have in my application. Because of course I have the package manager, composer, it's like npm or I think bundler for Ruby. So I need to run that on the start of my backend box so I can get all the dependencies in there. And then I wait for the database pod, and then I load I create a schema and load in all the fixtures. So everything is there. And the problem is there's a lot of magic involved in this, because you can't just, so you're mounting your source files from your host system into a Vagrant machine, and from the Vagrant machine you need to mount it into a running pod. But this is actually not enough, because then your permissions are all wrong. So you need to have another layer in between to fix the permissions for that use case. Also, permissions between Nginx and PHP FPM are hard to get right and wrong. But let's say I want to debug my application, and PHP is actually made for this use case. So if I go into my PHP file, I can set a breakpoint here. And if I press demo web, no. So the opens the browser, and of course nothing happened. Demo gods. Maybe I should press debug. So now I open the browser, started the request, and if I go back to my IDE, I see here, I'm in the debugger, I can step through, see what's happening, what I want to do, the usual stuff. Yeah, okay, another request. PHP, another request. Yeah, it sometimes happens with PHP if the browser just starts other requests in the background, and then you get. But this is PHP. It's still crap in some way. It is PHP after all. Yeah, another part is, let's say I have some unit tests in my application. I want to run these unit tests, but all my code is of course living in the container. My environment is there, my PHP is all there, so I need to execute them. And the good thing is that you can PHP Storm, you can configure in a way that you that there's a remote executor, and this remote executor is SSHing into this pod, so that's why there's this SSH container. And in this container, it's gonna run these unit tests, and I get my feedback in my so if you look here, basically you have to hard code this information, and then you can just execute these tests inside the container or inside the pod. So if all basically how you would develop on your local system, you can develop in the Kubernetes box. Also, I want to show, like in this box, this dashboard is provisioned by default, so you can see all your deployments running, your pods. You can take a look at the logs. So maybe not at the database, but at our container, and I can see the Nginx logs and also PHP. If something would go wrong, I can just take a look there. So this would be it for the demo. Only, or maybe you have a question, because I actually want to have like a dialogue with you.
Can you talk a bit more about the glue? Like, you said, so you can stick together all this stuff and some fancy stuff to make it actually happen.
Okay, so you want me to go deeper, like more technical?
Right, you just ask me, why not?
Okay, yeah, well, no, I mean, it depends on the audience, right? So one problem was first getting this, actually you can go back to the slides, was actually getting this Regin box stable. So I mean, challenges, the adoption rate was really a problem, because this is still a lot more complex than the usual, I have my Regin box, I have my Docker container, I just run it. And initial support was pretty high, because there were a lot of problems. People are new to Kubernetes, you need to basically teach them Kubernetes and debug this box at the same time. Sometimes you don't know where the problem really is. And caching is a real problem. You need to cache. I mean, if you build a container every time, if you don't cache your dependencies, you're going to refetch them all the time, and people are just going to commit their dependencies into the repo, which is also not really what you want. Complexity is still kind of too high. Yeah, file permissions are a problem, and fast file sharing is also a problem. And we still have a mismatch between containers, between development and production. Because this container, so in the beginning, I built a container here. So there's one container which contains PHP, Nginx, and SSH, which is not what you would usually do, but it helps really a lot. I tried using separate containers, for example, using the Alpine Nginx container, using Alpine PHP FPM, but then suddenly you get problems that, for example, the users mismatch. So Nginx is running as one user ID, PHP FPM is running as another user ID, and then they don't work as well anymore together, especially in this setup. And you can't just fix the permissions, because the files are actually living on the developer's machine. So this is, yeah, not the most beautiful Docker script, but you just need to fix all these things. A lot of these things you can also do for production setup. And for example, I hard code the SSH password. This in here. And also I hard code the SSH, like the SSH host keys. Otherwise, it would change every time you relaunch the pod, and then every time your IDE would complain that, oh, I can't connect to this pod anymore.
I have a question. Can't you do local development and have everything else in Minikube, for example?
Yeah, so Minikube is a good question. So when we started this project was in February or January, so there was no Minikube back then. And Minikube still has some problems, for example, that you can't, I think you can't mount hosts, like a host files into a running pod. So basically, that's out of the question right now. But of course, if Minikube ever is more mature and can do that, then I'm happy to ditch this thing. But there's so many special things to do. For example, one problem if you use NFS, you get a user IDs on the files from the host system, but they mismatch what you have in your container. So there's actually a bindfs running that, or not bindfs, but a fuse file system that fixes these permissions. It's running inside the Radiant machine, so I can, let me,
And why again do you need host files inside the pod?
So I can edit my file, press a 5 here, and it works. Because I'm editing the files on my system, my host system, and then I want to have them instantly be changed in the pod. That's what the whole shebang is about. Which I think is special for PHP because no other language works this way, or maybe Python a bit or these other scripting languages. But usually you need to restart some daemons to load the new files. I think for most languages.
And you can't do local development and point everything else to like the Minikube endpoints for the other dependencies?
That would probably also work, yeah. So I mean, another thing is, okay, I'm going to develop my application on my host system and all the other external microservices I just have in Minikube running at the same time. But the other hand, it might actually be a good idea, or maybe it should be a better idea than this one, the setup. Yeah, another thing is that, so what was really hard to get right was this machine. And there were some interesting bugs we found, which actually took a lot of weeks to find because they're hard to reproduce. For example, so there's one thing you need to configure in your host system if you want to use this box. And that is that you need to add this route to your system. So your system knows how to find, like how to go to the service, like the service IPs, the cluster IPs of the services. It's the only thing you need to add on your system. But the problem is then that if you try to connect to an IP address that you didn't register yet as a cluster IP address, your host is sending packet to the Vagrant machine. And the Vagrant machine, okay, I don't know this IP address. I'm going to send it back to the host. And the host is, okay, this still needs to go there. And they're just going around and around till the TTL is done. And you get a routing loop. And usually nothing should happen, but for some reason, this little box driver just crashes. And then it takes a time to recover, so it locks up. Then after 10 seconds, it crashes, and then it's going to restart it. And people are telling me, hey, my machine is not working because NFS is running over the same interface. So their NFS got stuck. And just detecting this problem was really hard. And some version of Littlebox don't set a MAC address on some interfaces, and then NAT is not working, and then your machine is not accessible, and you don't know why. And some recent problems we had were with NFS, that NFS connection would just drop and not work anymore, and was fixed by using Proto TCP instead of Proto UDP, which might be MTU related. I didn't have time to dig into that yet. TCP works well enough, maybe a bit slower than UDP, but well, at least it works. And also one complicated part is, so this is all on GitHub, this talk and also this box. So you can set up this box on your own. And this is how the networking looks like in this box. So things are easy to break here. It's still complex, but it works now. But it took time to get working. But the cool thing is that actually your pod interfaces are living on the same network as you have on your host, so you can directly connect to a pod. That's one of the reasons it's easier to debug, because you can just get the IP address of your pod and just connect directly there. No need to go around, do port forwarding, port mapping, whatever, you just go there directly. But I guess it's not the most supported or what most people do, and then things break. Yeah, so any other questions? Oh, okay. Maybe.
Are you also doing like using this for testing versions or something like this? Like trying to break or change the environment in specific ways to
Not directly. I mean, we didn't have to use it because this was basically used for greenfield projects right now. So we have one greenfield project that's using this box, and I think another one, a smaller project, and we didn't have to basically need to change things there a lot. But it would be easy or easier maybe, because now you have this Docker file, and here you could specify, okay, what PHP version you want to use, and specify exactly and install the right dependencies. But you still have the problems to synchronize these changes between developers. Even if it's in their repo, they need to rebuild it, the container. When you fetch the container from a registry, then you cache it. There's still so many problems, which you also have in all the other environments you use or other ways you would do that. But I think with containers, it's just a bit easier.
Why do you use SSH daemon when you use Kubernetes exec to run tests?
So the reason is that it would work. So for example, I have here I have a script run tests, which is just using kubectl exec to exec into the container, and it's setting some xdebug PHP magic. So PHP then connects to your host and says, I'm here, I want to debug, basically I want to execute something, debug something. But you can't trigger that from your IDE. And okay, I think I need to leave this presentation mode. And the cool thing is about this IDE that you can specify. Oh, let me check that. Here you can specify a remote PHP interpreter. And this PHP interpreter can do Radiant, I don't know actually the deployment conversions, or SSH, or in this version also Docker. So the easiest way to connect directly to the pod is just using SSH with hard-coded things. That's why there's SSH in there.
And why do you use FS? Can walk around the VirtualBox mount directory folder?
Yeah, so there's the VBox driver, so which is like the kernel driver from VirtualBox, but it's just slow as hell.
Hello.
Yeah, it would take, like if I would refresh the page here, it would take about 2 seconds. Okay, now I'm still in debug mode, I think, so I need to quit it.
And company service do you use to accept Nginx, your application at PHP, or do you have?
The database is also running there. So in this demo application.
I can see the reason Kubernetes just you have everything running in Docker.
Yes.
Docker, so you can actually run prop for
So let's say imagine now that there's another team that develops a microservice, and this microservice needs PHP, it needs RabbitMQ, and it needs MySQL.
Yeah, this case I understand.
So so we're not there yet. I mean, we're moving there, and basically this goes to make it ready. Another thing that, for example, I was thinking about is another use case is that you can use the Kubernetes API, for example, to provision like an auto updater into your Kubernetes box. So let's say basically another team would maintain this auto updater and update its own microservice in your development environment. And you wouldn't need to talk to this other team if they deploy a new version. They can just use the auto updater to update this stuff on your machine and your vegan, like a new Kubernetes environment. And I think where the power comes from. So I'm honest, like this is maybe not the best solution for this problem, but I think it's a new solution.
So can you say how much time do you spend doing that? Roughly, is it more weeks, months?
So in the beginning, I think it maybe took. I mean, it also was basically in the beginning also a tool for me to understand Kubernetes, because I had to build this box. I need to learn how to provision Kubernetes, how this works with like Docker, like on a deeper level, because there's of course some special stuff with Kubernetes and Docker, how they work together. I think that the initial thing took maybe 2 weeks, maybe 1 week. And then setting up for our first beta team that's using it was maybe a few days. And then, of course, it took some time maintaining it.
And the second question, do you use the box in your development pipeline or anything like that, or plans for that?
So the idea is when we do it for one team, I think, will we do it? No. We're still not sharing the containers between between development environment and, for example, between the CI system. And the most important part is that, especially in PHP, let's go there, is that, for example, you need these, okay, let's go to presentation mode again. That you need, for example, xdebug config and xdebug the extension, and maybe some other extension that's only, maybe you have npm in there because you want to compile some Node, like some JavaScript libraries in TypeScript or whatever. So development containers all mostly look always different than the containers you have in production, because you need a lot most of them more tools, and it's actually really hard to consolidate that. It's really hard. It's I won't say impossible, but you can spend a lot of time on that, making them match.
Okay, thanks.
Okay.
Yeah, thank you, Steffen.
Yeah.
Raise in the wrap up, and don't forget your adapter. And next we will hear Stefan from NavOps. He will give us a little awakening chat. So thank you very much.
Hi, let's welcome you from my side too. So I'm Stefan Haas. I'm a software engineer at the Univer Corporation, and I'm a member of the NavOps team. Working since 2009 with grid, cloud, and cluster technologies, however you want to call it. Mainly I was working on the grid engine. Maybe somebody of you knows that this is our general purpose distributed resource manager. And I was also working on our license orchestrator, which is a manager for allocation of licensed applications. But today I want to talk about NavOps Command. What is NavOps Command all about? It's a scheduling and workload management tool. What's the problem of Kubernetes? In Kubernetes, you do not have a pretty sophisticated scheduler. So, and as my slide says, we live in a world where you have physical limits, where you have quotas, and you do not. You have also limits on your budget. So you cannot have 1,000 nodes or whatever in the cloud or physical ones. So we want to get as much work done on your nodes you have as possible. So you want to meet the application SLAs. We want to analyze dev and production metrics to improve the processes. Our solution here is to combine resources into large clusters, and we want to eliminate silos. Therefore, we exchange the Kubernetes scheduler by our policy-rich scheduler. I need to do this a bit faster as I have only 10 minutes. So NavOps Command is a multi-container application. So it's divided into 3 different containers. We have on the one hand the application management container, which is responsible for managing the policies and the placement decisions. So where we want to place a part on which node. We have a bridge container, which is responsible for synchronizing the objects between the Kubernetes and our application management cluster. And of course, we have a UI container to have a nice web user interface. The end user is not interacting with NavOps Command at all. So the end user is still using the Kube API server as always. So this is our general architecture. As I said, we have this NavOps Command pod, which has inside the bridge container, the app management container, which is responsible for assigning the paths to the nodes. So the end user, as I said, is starting whatever web pod or some other machine via the Kubernetes API. We are monitoring the watches of Kubernetes via the bridge container. Our app management container feeds that into our scheduler, and the scheduler makes decisions where to place this pod on which machine. It makes the decisions on about what, for example, if you want to have a host with special storage bound to it, or with a special CPU within, or you need a bunch of memory. So all these things will get recognized by our scheduler, and upon that, it makes the decisions. So for that, I prepared a little demonstration. Let's imagine corporation called Webcorp, which is divided in 3 different clusters. We have production, we have development, and we have some other stuff. Below production, you have front end, back end, and some administration tasks. And below the development, you have also some front end and back end tasks you want to do. So this is the NetOps command web UI. On the left side, you see some policy management things you can change. You can you can change the pod placement. You can add access restrictions, or you can set runtime quotas. You also can do something like proportional shares, and you even can do something like interleaving. I will go into a couple of things in more detail. But first of all, okay. Let's go. For example, here we have, in my demonstration, I already added a couple of proportional shares. We have, as I said, we have the default department, we have the continuous or the development department, and the production department. Within the widest, it's a bit hard. You can see 32.4% of my overall available resources can get used by the continuous integration team, and 51.7% can be used by the production team or the production department. Beyond that, again, we have a 50-50 shares between backend and front end below the continuous integration team. So let's do a demonstration about that. So I want to run a couple of example jobs. So what I've done here, I've submitted 2 job controllers. Each of them is trying to run 10 jobs at a time. And I submitted 2 replication controllers. Each of them is starting 3 pods for as a front-end controller and 3 pods as a back-end controller. So I have here is a small watch command. I prepared this is a simple cube control which want to list all the pods. So you can see we have, at the moment, 10 backend jobs running. You might remember I said we have a 50-50 share between our backend jobs and the front-end jobs. So at the moment, there are only backend jobs running. This is due to the reason that the backend jobs were submitted first. So while I'm talking, hopefully, when the first backend jobs finish it, the first front-end jobs should start. Yeah, here's the first one. So after a couple of minutes, we should have some kind of 50-50. So sometimes 60-40 or 70-30, but in the middle, over time, we should get this 50-50, which we configured within our NetOps command web UI. And again, you might remember I said this job controllers wants to start 10 jobs at a time for backend and for frontend. So we should see here 20 jobs. This is not the case because of around browser. We have something which is called the runtime quotas. Where's my mouse here? And with these quotas, you can limit your pods. For example, open this. I limited the projects, so back end and front end, to combine 10 running pods at a time. This means 5 back end and 5 front end. But you can do more things with quotas. Let's see. For example, let's have a look at the quotas which are set for the production environment. So here you can see I limited the front end application of our production environment to 500 megabyte of memory. And I limited the back end application to 600 megabyte of memory. As soon as the application would reach that limit, it will get a signal, please do whatever, but you're not allowed to use that much memory. And after a couple of seconds, if the application is still using that much memory, we simply kill it. So this is just an example. Let's get back to the proportional shares. This one. So just to show you that this is not only a mock-up, that there is something really happening, I'm changing that to the backend is now allowed to use 11%. Save that. Takes a while. And go back to our watch command. And again, after a couple of seconds, we should see those changes here in the distribution of the backend and front end jobs. Yeah, let's get back in a couple of seconds when we see the changes maybe. What you can do also is we have some kind of fair share, which means the influence of past resource usage. As you have seen, we do not have always the 50-50 shares, or we haven't had the 50-50 shares between backend and frontend. Sometimes it was 60-40 or 70-30. If you can make the scheduler aware of this distribution and say, okay, the production team backend had in the past 20% overusage. So in the future, therefore, front end will get some kind of, will get back its resources. So you can say, okay, I want to get front end another 10% back of the 20% they had, say, had too less in the last couple of hours, minutes, or whatever. Let's go back if we can. And now here you can see this is merely the 10%, 90%, or it is the 10%, 90% between front end and back end. Okay. So, here. You also can set. What I want to show you is how you interact with all these restrictions, proportional shares, and whatever. And for that, we create projects, and those projects are get tied to your pods you want to send into Kubernetes. You also can add user groups, and you can also add so-called application profiles. We have here 2 application profiles. For example, the backend and the front-end application profile, you can set, as you can see here, mandatory resource labels. For example, backend needs 50 megabyte of memory, and front-end needs at least 40. megabyte of memory. So the scheduler takes that into its decision, and that's where it places the pod on which node, or if there is no node available anymore, to start up some nodes on whatever Amazon EC2 or Google Cloud, wherever you want. So any questions on that? I think my 10 minutes are done.
Yeah, thank you very much. Do you have any questions right now? If not, you can reach out to Steffen. Now, after the official part, we have please stay. There's food in this room. There's cold beer and mate, etc. in the fridge. And one thing, in my personal account, at the next meetup, I'm going to have a little talk about Kubernetes ingress and the Kubernetes Nginx ingress controller. They just released 0.5. They say not. Yeah, they say it's not production ready, but we use it already in production. And I made some patches, and I'm going to introduce the concept of ingress and especially that controller. So come next time to the meetup. So thank you for coming. Grab a drink.